Welcome to lesson 1.5. In this lesson, we're going to look at 7 different graphs, parent functions, and some characteristics go along with each one. We'll look at domain, range, decreasing, increasing, constant intervals, x-intercepts, y-intercepts, things like that. Okay, so hang on, here we go. All right, this is lesson 1.5, parent functions and their characteristics. We're going to look at I think 7 different parent functions, and I'm going to move through them fairly quickly, writing down some of the characteristics of each. And so if you need to pause the video, do that and catch up, and then proceed as at your own speed. Okay? So this first function, we have just this line that passes through the origin. It's going from the bottom left corner up to the top right corner. And this is the parent function. This is a linear function. Also called, this particular function is called the identity function. Linear or identity function. The equation for that is y equals x. So the domain, remember domain is all x values, so we're going forever to the left, forever to the right. And so this is all real numbers going from in interval notation from negative infinity to positive infinity. The range, the y values, it's going down forever, it's going up forever. So again, negative infinity to positive infinity. It has origin symmetry. Every point is reflected over the origin. And since it has origin symmetry, that makes it an odd function. It has an x-intercept. It crosses the x-axis at 0, 0. Which turns out that that's also the y-intercept, 0, 0. And it is always increasing over its entire life, entire thing. It's the interval from negative infinity to positive infinity. It's always increasing, so it does not decrease. It's never constant. Okay, that is the first linear identity function. All right, bottom of the page. So this is a parabola. And so the name of this is called a squaring or quadratic. Squaring function, also called the quadratic function. And this is y equals x squared. Domain, again, it's going to go forever to the left, forever to the right, so the domain is all real numbers, from negative infinity to positive infinity. The range, however, this does not go down forever. The minimum is at 0. So we're going to put 0 with a bracket to show that the 0 is included, and then it does go up forever to positive infinity. So from 0 to infinity inclusive. This one has symmetry. It has y-axis symmetry. And that makes it an even function. It has an x-intercept at 0, 0. It has a y-intercept at 0, 0. It is increasing to the right of the y-axis, so it's increasing from 0 to infinity. It's decreasing on the left of the y-axis, which is from negative infinity to 0, and it is never constant. Not constant at all. That is a null set is what I'm putting there. Okay, same thing up here at the top, null sets. All right, let's go to the back. All right, so what this looks like is someone took a quadratic and kind of broke it at 0, 0 and flipped the other side down, but that makes this a cubing function. Cubing function. Y equals x to the third power, x cubed. Domain, forever to the left, forever to the right, all real numbers. Range, forever down, forever up, all real numbers. This once again has origin symmetry, which means it's an odd function. It has an x-intercept at 0, 0. We're getting that a lot, aren't we? And y-intercept 0, 0. And this one is increasing over the entire interval. It kind of flattens out when it gets close to 0, 0, but it always increases. This increases over the entire interval. So nothing there and nothing there. All right. Moving to the bottom of the page now. Okay. All right, so this is an exponential function. Exponential. And the equation would be, this particular one that I've graphed is y equals 2 to the x power. In general, it's y equals some number a to the x power, but this particular one is 2 to the x power. Domain, it does go forever to the left, forever to the right. So all real numbers for the domain. The range, it never goes below the y-axis, and it never actually, the x-axis, and it never actually hits the x-axis either. So it's 0 to infinity, non-inclusive. Does not include the 0. This does not have symmetry, and because of that, it is neither even nor odd. Since it never hits the x-axis, there is no x-intercept. It does have a y-intercept. If I put in 0 for x, I'm going to get 1. And so 0, 1 is the y-intercept. And this is increasing also. It looks like it's just a flat line to the left, but it's not. It's always increasing. It's just increasing very slowly over to the left. Okay. All right. So this graph, I know you talked a little bit, well, I don't know if you got tutored in Algebra 2 last year, but this is logarithmic. This is a logarithmic function. Logarithmic function. And this particular equation would be y equals log base 2 of x. Log base 2 of x. There's different, you can use different bases, but this is base 2. Domain. Now this one does not go forever to the left. In fact, it goes to the y-axis. Not included, but it doesn't touch the y-axis. So this would be, the domain would be 0 to infinity, not including the 0. The range, though, it does go down forever, it goes up forever. From negative infinity to infinity. Does not have symmetry. So it is neither even nor odd. It is always increasing. It increases at different rates. But well, I'm sorry, let's do the intercept first. So it crosses the x-axis at 1. So 1, 0. And since it never hits the y-axis, there is no y-intercept. And it is always increasing. Oops. Except not from negative infinity. From 0 to infinity is increasing. It does not decrease. All right. Next one might be a little bit hard to see. I probably should have zoomed in on it a little bit more, but what we have is a hyperbola in the first quadrant and then in the third quadrant. And so this is called the reciprocal function. Or I think it would be okay also to call this a rational function. And this is the equation that I put in to graph. This is y equals 1 over x. 1 over x, the reciprocal of x. Rational meaning a fraction, so that's why it's 1 over x here. The domain, well, it does go forever to the left, it does go forever to the right, but it does not exist at 0. So it's everything except for 0. So we're going to say negative infinity to 0, and then 0 to positive infinity with parentheses on the 0 to show it's not included. Same thing with the range. It does go down forever, it goes up forever, but it does not cross the x-axis. So negative infinity to 0, 0 to infinity, everything except for 0. This does have origin symmetry, so that makes it a non-function. It does not have an x-intercept, never crosses the x-axis. It does not have a y-intercept, never crosses the y-axis. And this one, it is decreasing from negative infinity until 0, and then it's decreasing again from 0 to infinity, but it's two different branches, and so it's always decreasing, but it's in two separate pieces. So negative infinity to 0, it's decreasing, and then 0 to infinity, it's decreasing. It is never increasing, it is never constant. Okay. All those other graphs I did on Desmos, but I could not figure out a way to graph this last one on Desmos, so we're going to do this with my hand together. Okay? So what this looks like, I'm going to start at 0, 0. It exists at 0, 0, and then it's just goes straight across until I get to 1, and then I have an open circle, and it jumps up a line to 1, closed circle, cross to an open circle, closed circle, cross to an open circle, and it just repeats this pattern forever. And even down into the third quadrant as well. All right, so this is a step function, and it's also called a piecewise function, and we'll talk more about piecewise functions in another week or so. Okay. The equation for this, I've seen this written different ways. I have seen this written with like double absolute value lines like this, or I've seen it written with brackets, like double brackets. Y equals a double bracket of x. Okay, and either way is fine with me. But this is read as the greatest integer less than or equal to x. The greatest integer less than or equal to x. Okay, so the domain is all real numbers. It goes forever to the left, it goes forever to the right. Every single point is accounted for because right above all those open circles are closed circles. And so every point is accounted for. And so it's negative infinity to positive infinity. The range, however, is only just the integers, right? It does not, for example, I don't get a y value of 0.5. That doesn't exist. It exists, 1 exists, 0 exists, 2 exists, 3 exists, but not those fractions in between. And so the range is going to be, we're going to do this by dot, 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 -3, -2, -1. Actually, I should use set notation here. There's not really a good way to do this in interval notation. I guess you could, but I think set notation works better here. Oops. We need dot, dot, dot here to show that it goes on forever. And those are braces. All right, symmetry doesn't really have origin or y-axis symmetry, so we're going to say none here. So it's neither, oh, I'm sorry, I'm probably off the screen, aren't I? So it is neither even nor odd. I have x-intercepts. I have an infinite number of x-intercepts. It's all points including from 0 to 1, including the 0 but not including the 1. Y-intercept is 0, 0, just the 1 point. The y-axis, I only have 1 point, it's that closed dot at 0, 0. It is never increasing. There's no interval where it's increasing. There's no interval where it's decreasing. All the intervals are constants, and they all last for 1 unit, almost. Okay, so we could say, the constant intervals are from, we could say from -3 to -2 with parentheses, and then -2 to -1, and then -1 to 0, and you get the idea here. Okay, we have an infinite number of constant intervals here. All right, so those were 7 functions and their characteristics. So you should know those. And I think, hopefully you're pretty familiar with all of them. You're probably not that familiar with logarithmic. You're probably not that familiar with, you're definitely not familiar, I don't think, with the step function. And maybe not as familiar with, what do we have over here? The reciprocal function, but you should know that. You should have been, y'all did rationals last year, so you should be okay with that. Okay? So that was lesson 1.5. No assignment for this one, no practice, but it will be covered on the test, and the test is coming up this Friday. Okay, so I will give you, I will attach a review by Wednesday. I'll for sure attach a review to the page, the Schoology page, so that you can start reviewing for the test on Friday.